Hi, my name's Bob Ryan. I'm Director of Public Services for the City of College Park. I'm also a member of the Planning Committee for the Mid-Atlantic Life Safety Conference. As a graduate of the University of Maryland Department of Fire Protection Engineering, it's my pleasure today to introduce Dr. Jim Milke. Dr. Milke is Professor and Chair of the Department of Fire Protection Engineering. He will introduce you today to some of the exciting research that's been conducted at the university that impacts everything from wildfires to experiments on the space station. In addition to Dr. Milke's academic achievements, he's also an alumni member of the College Park Volunteer Fire Department. And I think you'll enjoy and learn from Dr. Milke's presentation today.
So it's a pleasure to talk with you today and speak about the use of technology to address contemporary challenges we face in the fire safety field. The topics I'm going to talk about today, first of all, I thought I'd just talk in general about some of the research we do in fire protection engineering at the University of Maryland, and then zero in on two topics in particular that I think would be of the most interest to this group. So first of all, the variety of research we do, we've been doing a fair amount of wildfire research for several years now in the department, and some of that is to look at the spread mechanisms for fire as to why they travel across a set of grasses, or develop brands where the brands are actually the more dominant way as to why a wildfire spreads. So there's a lot of interest that we're spending right now and time on understanding fire brands, how they get generated, how they travel, and so on. These are a set of slides in the bottom part of this slide that shows some fire brands on the lower left that we create for our experiments. There's a detailed thermal map of a wildfire through camera technology. And then finally, as that brand lands on a substrate of some sort, be it maybe a wood deck or other combustible item, then how does that heat up that substrate to the point that that substrate eventually ignites? Just in the news fairly recently is one of the faculty's research in what's called cool flames. And so he's been involved in looking at fires in microgravity applications, or fires in space, if you like. And one of the really significant developments in this has been looking at these cool flames, as he's talked about. This just been discovered specifically this year. There were some hints of it several years ago, but they finally nailed it down to look specifically at these cool flames. And have observed 150 flames now in the International Space Station, having experiments done there, led by one of our faculty, Peter Sunderland. The cool flames are burning only at 900 degrees, only 900 degrees, where usual flames are up on the order of 3,000 degrees. And these have an impact potentially in terms of fire safety, though one of the things we're finding some of our research is getting involved in, because we understand fires and understand combustion, could involve other applications. And in this, potentially a cool flame might be a really interesting development for new engines that would be more fuel efficient, less polluting, and so on. So you see the photos on the right with an astronaut conducting one of the experiments on the space station, and then what the hot flame looks like compared to a cool flame. You can see the scale. These are about 10 millimeters, so about half an inch in diameter, so relatively small at this stage. So there would certainly be interest in trying to scale that up to some point. Lithium-ion batteries is an area where there's been a fair amount of research in the fire protection community by several entities over the years. We've been involved in that now for probably about 7 years now, I think, where our research started out with Ford. As Ford was interested in the development of electric vehicles and comparing the hazard associated with an electric vehicle compared to a gasoline-fueled vehicle. So a piece of it was understanding what it takes for a battery to go critical after it's been exposed to fire, where it starts acting like a flare, such as you can see in the photo at top left. The research has now continued looking at battery storage systems now for buildings, building applications where you could have these huge array of lithium-ion batteries, and the research now is looking at cascading failure. So if a fire starts on one battery, what's it take to go to the next battery, to the next row of batteries, and so on and so forth. And a piece of that research is also now looking at how to put those fires out, and looking at some strategies with nitrogen inerting, as you can see in the bars. So the SP is looking at spread from one row to the next. And you can see from the bar charts of going from 1 to 2, from one row to 2 rows. The strategies are pretty similar, other than the high concentration of Novec, a clean agent. And that continues going from rows 2 to 3. Nitrogen inerting has pretty good advantages too at the same time. And then going from rows 3 to 4, again, nitrogen and Novec are the leading suppression systems, or suppression capability, have the leading capabilities, where the nitrogen actually is the key performer at this stage. So conducting some research there to see how do you control fires that we're going to start facing. We hear about them in electric vehicles, but as these storage systems are going to be in buildings in lieu of emergency generators and those sort of things, or just ordinary batteries, it won't be too long before we start seeing these very significant fires, I suspect, in buildings. One research area that we've just recently gotten involved in, an area I've had involvement in, is looking at the social inequities of fire. We've had some research actually going to the bottom line. Back in 2017, we did a study for the textile manufacturing facilities in Bangladesh after they had some very serious fires there, and looking to improve workplace safety. So we've had involvement in that area for years, and continue to have interaction with folks in Bangladesh at the Bangladesh University of Engineering and Technology, as they've done some fire safety workshops and trying to improve the situation in Bangladesh. Otherwise, the research this year has looked more at the residential environment, and looking at, here in the U.S., for example, as you may know the fire statistics here we have in the States, the 3 leading ethnicities with high fire death rates are Native Americans, Alaskan Americans, and then African Americans. So looking to understand why these fire death rates are as they are, some of it being attributable to poor electric systems, poor heating, those sort of things. But further, after we understand the problem, we'll be trying to find out, what do you do about that, right? What do you do about that? In the international market, we've been involved as well very much with looking at, again, a residential environment and settlements or communities that are called informal settlements. So these are settlements that develop ad hoc. They're not developed by the community. People find materials from wherever they can for housing. These are low-income housing, obviously, or maybe migrant workers that are there. And South Africa is where we've spent a lot of attention, reaching out to a university, Stellenbosch University at South Africa, and one of their faculty, Richard Walls, has been heavily involved in. And why South Africa is interested in this, because the greatest number of fire deaths that occur in South Africa occur in informal dwellings, more than any other type of building, any other type of facility. There are 5,500 of these fires occur annually in informal settlements. So you can do the math, and that's something like 15 or so a day that happen in these settlements. Those numbers have doubled in the last 15 years, by the way. So it's an increasing situation that's going on there, and just devastating consequences. I showed the one slide there on the right of one of the incidents from 2018, where 1,000 homes were damaged, and 5,000 people homeless as a result. Very often, because these homes are stacked right next to each other, a fire in one is going to mean there's going to be a fire in 10 or 100 of these homes fairly easily. We've done some evacuation analysis so far this summer to try and explore improved evacuation strategies in these informal settlements. All right, The two topics I'd like to spend a little more time on is on fire as a weapon and or as a means to provide active violence with fire, and pyroterrorism. It goes by several different titles. This was part of a seminar that we gave for incident commanders in the DMV with the START Center on campus. This was right before the pandemic caused closures and so on. This was we provided these lectures in February of 2020, I'm sorry, in February of 2020. And so looking at again, utilizing the knowledge of fire safety and fire protection engineering for these threats, and what do you do about these threats, perhaps more importantly. So fire as a weapon, this is defined in these terms: in the use of smoke, fire, or flammable materials, normally used with other attack vectors, other means that can confound incident response, and which normally requires an integrated multidisciplinary effort for incident stabilization. So that's a definition actually that was provided by one of the presenters at that workshop from Prince William County. Why use fire? It is a very reasonable question. This is again from Prince William County, that you end up with a list of reasons. I've got 10 of them here altogether that you can pick any one or a combination of the group to see. So why use fire? Why would a terrorist or somebody committing a crime want to use fire for their purposes? It's low cost, it's low technical expertise, it's easy to get materials, there's prolonged duration, there's very high potential for casualties. You get lots of media coverage very often in these incidents. Damage can occur even if the suspect has been neutralized. That fire is continuing to burn, continuing to cause damage. So there are any one of a number of reasons why someone wanting to commit one of these attacks would use fire as the weapon. There are a couple examples we can talk about, and one of the most devastating was in Mumbai, India, back in 2008. With an attack involving fire, involving several facilities simultaneously. There were 10 attackers, 4 groups, 174 deaths, 308 injuries. There were 7 targets altogether, and affected American, British, and some public safety targets. So high-profile sort of facilities, and received a lot of attention on the subject. I will say, give a shout out to West Point. And Joseph Pfeiffer in particular. So West Point has a center there looking at pyroterrorism as a special area of study at West Point. In addition to the big incidents that hit the news worldwide, there are also many of these minor incidents that occur, and we don't want to dismiss that and only look at those really high-profile incidents. So there can be fire used as a weapon in domestic incidents, in situations with mental instability, barricades, protests, just arson cases, gas explosions, clandestine chemistry drug labs, bomb makers, fires used to mask some other criminal activity. And for any of you in the fire service, you could probably think through examples where you've seen this happen in maybe several incidents over your career. Here's one that occurred now about 5 years ago in Fairfax County, where there was a driver that intentionally drove their SUV into a diner multiple times. So he hit it, backed up, sort of thing. Then poured liquid on his body, lit himself on fire while inside the building, that also then exposed the diner. There was a 74-year-old man that was struck by the suspect's vehicle that died in the incident. There were 3 others that were injured. And off-duty Fairfax County police officer happened to be in the vicinity and was able to respond quickly to this situation. But nonetheless, have an incident there with just a single individual, and probably didn't go any further than the local news. So what kind of facilities are potential targets? So some of these may be relatively obvious to you, or we've seen in our history. So a nuclear power plant would be perhaps the gold standard as a place to attack, and happily there's excellent security there. But you can look at our U.S. Capitol, airport terminals, college campus buildings, synagogues, and we've seen attacks already in several of these type of facilities, in government buildings and religious facilities, campus buildings, airport terminals. But also one of the high-profile targets are wildfires for people interested in pyroterrorism, because it can create a lot of damage. It is, as we see that in incidents that are occurring naturally or from lightning strikes and so on, can involve thousands of acres, right? So it can really wreak havoc with a particular area, take resources to deal with that, and potentially take resources away from some other source that they're really interested in. There are several scenarios we could talk about associated with those incidents. The one I'd like to mention here would be these kind of incidents that would involve an exterior facade. So this doubles with incidents that we've seen with exterior facades igniting due to just normal circumstances, I'll call it, or accidental fires, but are certainly a prospect for an intentional fire. With these exterior fires in a 5-year period here in the U.S., altogether, the exterior wall fires represent 3% of all structure fires, 3% of the fire deaths. So that's pretty much just a straight correlation sort of thing. But 8% of the property damage. So that these small number of fires are causing a disproportionate amount of property damage, which is again attractive to the pyroterrorist in the name of trying to create this huge event. Exterior wall fires, how do they get started and such? So almost half of them, 42%, get started on the exterior wall surface itself. About a third of them, the area of origin is not the exterior wall, but the first item ignited was the wall. And then the final quarter or so did not initially involve the exterior wall. The fire was inside the building, started inside the building and then spread to the exterior wall. There's a really outstanding reference for exterior wall fires or facade fires from White and Del Casio's, available through the Fire Protection Research Foundation website. Any of their reports are free of charge, so anyone interested in exterior facade fires, this is an excellent review. Recent fires, there have been several of these around the world that have occurred. We see a lot of these that seem to occur in the Mideast, but they occur in the U.S. as well. And we've had several incidents in the U.S. as you can see here, and I'm not going to read all these to you for sure, but you can see that there's several continents that are involved with incidents that so it's very much a worldwide issue of having these exterior facade fires. The facades vary a bit in design, though the commonality is that there will be an exterior skin of some sort that encloses a combustible insulation, typically a polymer insulation. So they can be, this one with high pressure laminates has clear paper on either side of it with the foam insulation inside. There's some exterior insulations that involve some stud material, so it gives you some air cavities, metal composite, structural insulation panel, which is again kind of a sandwich board, and then solid timber paneling is possible too, pretty thick by comparison, so it doesn't have that plastic insulation there, but would also be one design that is attractive to architects these days. The consequence of these exterior wall claddings, of fires involving exterior wall claddings, involve rapid surface propagation, as you perhaps have seen some video footage of fires that in high-rise buildings where it doesn't take very long for multiple stories or perhaps the entire facade to be ignited. The cavities are very important because that can end up being a bit of a flue space for the fire to spread. And enhanced flame spread with a very nice flue that would be there, and those flue spaces can be created either through installation flaws or potentially that insulation melts through the initial fire exposure or as a result of initial fire exposure. And there can be fire spread to other floors, so the exterior facade can be the means for a fire to start on the 3rd floor, ignite that facade, and get to the 4th floor, 5th floor, and so on, and have the fire involve now multiple floors of the buildings because of transmission through the exterior facade. The spread mechanisms themselves vary a bit. There are 3 possibilities, or 3 general possibilities. One's just along the exterior, and this is where there's a combustible exterior surface, which is basically all of them, or all of them except the metal skin one, can involve a breach of the exterior surface. So if it is a non-combustible cladding that could be penetrated with some object, just thinking through the acts of someone wanting to provide an intentional fire, or it can be through degradation of lining, development of cracks, and so on. Fire can start inside the flue space potentially, and then the other spread mechanism is falling burning debris that now starts fires at lower levels or maybe around the base of the building. Looking at a couple situations, the interior fire spread problem. So this is depicted in the diagram on the right of having some fire in an interior space. Perhaps it gets to a post-flashover stage, flames exit the window, and now expose that exterior facade. So that exterior facade is now ignited and spreading along the outside, or it could get into the cavity within the wall space itself. Scenario where this occurred was the Grenfell Tower fire back in 2017. That was hit the world news for sure back at that time as a result of the huge number of fatalities. It was an apartment building with a lot of low income or people, or at least subsidized housing. The fire was initiated in a refrigerator in the apartment. And after about 18 minutes or so, fire having developed inside that kitchen area, broke the window and spread to the exterior cladding. That particular cladding that was there originally for energy conservation purposes, so a noble goal for the cladding, but nevertheless ended up being a devastating fire with basically the entire exterior skin of the building involved in fire, and then fire spread to several multiple floors. The fire spread on the exterior. Here there are possibilities that you can think of, and you see already with some garden apartment fires and those sort of things, with a barbecue grill on the balcony type of situation. That again, for those of you in the fire service, you've likely attended many of these fires over the years, and it's also why a lot of garden apartment complexes don't allow them, or some of the county ordinances don't allow them to be on the balconies. But having an exterior accidental fire through barbecue grill, maybe fireworks on a balcony or around the outside of the building. Wildfires are certainly possible. Having a vehicle accident, so not an intentional necessarily, but just a truly accidental event of vehicle impacting the building. And then having an exterior intentional fires, of course, there with very often dumpsters are placed right along the exterior of the building. So start a dumpster fire. Having a vehicle accident again, but this time purposeful, or potentially an incendiary device placed right along that outside edge of the building. Case study for this situation was in Dijon, France, back in 2010, with again, a membrane type of system, so skin, outside skin on the building, mineral wool fibers, but having polymer presence with the insulation. Cladding was ignited from the trash containers. That's that dumpster scenario I just talked about. This was accidental in this particular case, but you could envision certainly why that might be a non-accidental situation quite easily. With the prevalence of trash containers right along the outside of the building, a lot of buildings. So how do you prevent these things in the name of again, intentional fires, and how can we make things difficult for the pyroterrorist? Can certainly check and enforce that properly rated exterior cladding panels are installed. the installation is not trivial. There are details that need to be followed in how they're attached and what kind of air gaps and so on are provided. Making sure the right materials are provided, and there hadn't been some value engineering, is the quote, or the term used, to provide some other insulation besides that was rated as part of the assembly. Locate trash containers several feet away. Don't put them right next to the building. Put them out in a yard separated perhaps 10 feet from the building. Would make all the difference in the world with that. Prohibit vehicle parking. So don't let vehicles park and maybe have some sort of obstruction to prevent vehicle impact on the exterior of the building. And then if anybody's doing welding near that exterior cladding, of course, extreme caution needs to be provided there because that's an easy ignition source. When you look to the interior fires, as we look to what influences fire severity in general due to any kind of fire, fire severity gets addressed in terms of a peak temperature, generally, and then a duration of that fully developed period. Once the fire becomes fully developed, once you get to a pre-flashover fire, how long do things burn after that? So this graph I've got on this slide is completely hypothetical, understand, but would be indicating a fire that gets to 1700 degrees and lasts for about 2.5 hours altogether from start to finish, about 2 hours of which are in that fully developed period. Pretty substantial fire. And all that gets affected, and the likelihood of that type of scenario or some other graph that we draw there depends upon the amount of fuel that's present, what's the room, what kind of materials are enclosing the room or rooms that are involved, what are ventilation possibilities, be it natural ventilation through open windows, open doors, mechanical systems that are on, and then the area and height of the room. Some basic parameters that would be utilized in an assessment as to how severe a fire could happen. So in preparing for pyroterrorism, there are several things that I can recommend, and one is to coordinate with multiple agencies, and that police and fire are typically going to have some activities associated with an event like this, with a crime being committed of one sort or another. Fire department, of course, trying to deal with the incident. Ahead of time, you can identify buildings that may be particularly vulnerable to pyroterrorism. And virtually any building is possible, but what are the high-profile targets in the area, such as I showed in that previous slide, or one of the early slides, where there may be a religious facility or a government building, those kind of places in a community that would be more interesting for the pyroterrorist to deal with for newsworthiness or impact. Understanding fire dynamics, to understand how fires develop and spread in buildings is important. So understanding the dynamics of a fire, to understand, so what's the possibility of how much of that exterior facade will ignite, or how much of a fire that will develop in the Silver Diner, excuse me, or in a townhouse, even where there can be these kind of incidents that would be created. Need to appreciate the role of fire protection systems in buildings, and then for a building with sprinklers in it, you would imagine that the risk of a serious fire would be a fair amount less, assuming that sprinkler system has not been disabled, right? Or whatever fire protection systems are present in the building that would have an impact here. And then pre-planned messages for affected individuals, and that the individuals in that particular development or community, that facility, need to get a message as to what's going on, so we can direct them as to how to get out of harm's way. And to pre-plan those messages would be important. Along those ways, in that area, I can say that, again, some research we've had had some involvement in the department is, what's the structure of those emergency messages? What should be the content of them? And that just recently, the wireless emergency alerts have been instituted, increasing character limits of a message from 90 characters to 360 characters. So you have 270 more characters to use now. What are you going to do with that? Right? The message needs to be specific and succinct, useful, not confusing, right? All those kind of things that will cause more problems than if you didn't provide a message at all. There was a thesis by Jessica Dorman a couple years ago now that developed a tool to construct messages for WIA. Her application was specific on wildfires, but there's nothing about this application that's tied solely to wildfires. The information, the approach is very applicable to any fire situation. So, as you get content, we all I get messages here at the university. If something's going on at the university, I get an alert where there's a message here, and it needs to, you want that to be useful and so on. So what should be the content? Well, it should identify who or which agency is sending that message. Here on campus, I get University of Maryland Police Department as an example. It sends out a particular message. What's the hazard? In that we could get messages for a whole bunch of reasons. This is going to be a fire potentially, or maybe a bomb threat, or whatever. So you have to identify what's the hazard. What could happen as a result of that? Where is it now? Where is this hazard? It's on the second floor of a particular building, perhaps, and identify that. Where's it going? And that's perhaps a little more relevant to wildfires in that it's in this particular community and it's traveling west or it's traveling east. But if there is some movement of that fire, it'd be useful to tell people that the fire started on the second floor. We're seeing a lot of smoke on the third floor. Where's area refuge for evacuees? Where do we tell them to go, right? How long do you have? And again, in building fires, it's usually not very long. You need to go now. How about if you're in the building next door? How about the building 3 buildings away? So having some sense of urgency. Again, wildfires, that urgency is a key thing in that you better start packing your belongings in about half an hour. You may need to go, kind of thing, or got to go now. Don't pack anything. And then what kind of protective actions should you take other than perhaps evacuation? Is there something else that should be done? And this is just a template of the prompt or the tool that she put together that has preloaded answers. And this I'd encourage for any of our events here in looking at pyroterrorism situations where you've got to get a message out in a hurry. You don't have half an hour to put a message together, a meaningful message. You can have that preloaded on a template and have some standard canned responses ready to go. Would be the suggestion. All right. Situational awareness, where we get our smoke detectors or some sort of fire detector, or whatever device, maybe a manual pull station that gets activated, and we sound horns and have strobes go off and so on. Tell people that there's a fire in the building. We don't tell them a whole lot else, though. Right? Don't tell them a whole lot else. With today's fire alarm system, there are addressable devices, right? And these have been around since the 1980s, so almost 40 years old since addressable devices, addressable smoke detectors, addressable manual pull stations have been put in, even addressable notification appliances available now, so that you can know if a smoke detector is operated, you know it was that detector 102 in that green room on the slide that operated, and that tells you where to go. Right? We've taken it somewhat for granted. Back in the good old days, when I was a firefighter, and you go into a building before addressable devices, and you'd have to walk down the whole building to find out where a smoke detector is operated, where you got an automatic alarm, or find out maybe where there was just an overheated light ballast, as it turns out, right? Or whatever. But you'd have to walk the whole building. You don't have to do that now, because we know where the fire is. We ought to be able to take some advantage of that, though, besides just sending it to the annunciator panel. We can send out that information through an IP address so that it can be available on a flat screen, perhaps for the incident commander to be pulling up the plan for a particular building. Seeing in particular here, I'm showing a red alarm in the manufacturing room of this particular facility, so that now the incident commander doesn't have to walk inside the building necessarily. They've got it on an iPad or perhaps on a phone that they can see where this fire is, and that's current technology. That's not new. That capability has been around close to 15, maybe 20 years now. So the proposal I'd have in let's use technology to address a contemporary challenge that I'd still think is a challenge. And that is, why can't we use a fire alarm system as an information system as opposed to, I'm just going to make a lot of loud noise and not say much of anything otherwise, other than to say, there's a fire, good luck finding it, kind of thing. And there are three parts of being an information system. We have sensors to provide improved information. So there are a lot of sensors in buildings, awful lot of sensors. And there are motion sensors, there are humidity sensors, there's a thermostat on the wall, so on. So why can't we take advantage of those things and use them to supplement the fire sensors to provide more information about what's going on in a particular room? As we collect that information from all these sensors, these plethora of sensors in buildings, we're going to have to downsize that a little bit and distill that vast amount of data, because now we don't want to overload the incident commander with information where they'll get this table of 100 sensors in the building and all with printout and saying what's going on in those sensors. That's not going to do any good. So it's going to need to be distilled down. So there's a piece of work that has to happen there. And all get down to a succinct message, right? With maybe a couple key items of what's going on in a particular space. And like I say, I just gave an example. There are all sorts of sensors in buildings in a contemporary building these days, with temperature, humidity, flow meters, CO2 sensors, CO sensors, that we should be able to learn some things, lighting controls that we should be able to learn some things from and take advantage of to understand what's going on in a particular situation with a fire. Again, as I thinking back to those good old days I talked about being a responding firefighter, you go into a building, you don't know what to expect. You knew there was an automatic alarm that went in the building, or something's going on. Would it make a difference to you if you knew that there's a little haze in that room 102, or I can't see my fingers in front of my face in that room 102? Would that give you a different mentality walking into that building? Or if I had a heat sensor to say, it's 500 degrees in that room as opposed to it's 100 degrees in that room, I'm going to have a different thought process walking into that room, I would think. I'm going to potentially bring different gear with me. As well as just have a whole different mindset of what I'm getting my mind ready to prepare for, what I'm going to have to deal with. And information is useful for building occupants as well. I saw this sort of depiction from a presentation, it's got to be close to 15 years ago, of having a smart system in a building, and where because we know where the fire is, right? Because we know where the fire is because they're addressable detectors, why can't we then whenever the fire alarm goes off, light up the exit way through a little string of lights along the floor, if you will, that would highlight the path. So in a completely dark room or in a very smoke obscured corridor, you'd be able to see the pathway, and that outlines the door. Boy, that door is really obvious as to where that door is. So you know where you're going, and you could take that a step further if you want to overachieve here a bit, with not just having the lights on, but because we know where the fire is, we could change the lights if the lights are directing you by the fire or to the fire as opposed to away from the fire. You could have blinking lights that are traveling lights sort of thing to further enhance the system here. We can also provide information to building occupants because we can provide motion sensors to see how many people are in a particular stair and where there's a queue and where they're moving. And all that information can be fed to our phone, right? You'd have to opt into this system, of course, for your particular building or buildings you're in, but you could be looking at some directions, just a GPS sort of style that you use perhaps to get to a whole assortment of locations. Why can't we use a GPS for a building to get people out, and that would come right to your phone, potentially, and not just GPS, but it could also tell me not the route to take, but just like GPS does, hey, don't go this way, there's traffic that way, go this way. That technology is all available. I'm not talking about any technology that doesn't already exist. Provide information displays. And this could be, again, for the incident commander. And this is the Kim Engineering building on campus, where there's this one room that's colored in red, and we could use a red color for a particular temperature that gets achieved, or a particular smoke level gets achieved in that particular room. And you see there's a room next to it that's gray. So that's perhaps a lesser amount of smoke that's there. So you have more of a sense of what we're to expect in terms of conditions in a local area of a building. Now let's go one more step here. Right? Let's think about heads-up display. We have heads-up display for fighter pilots, right in the face mask of them. For any of you that drive motorcycles, there's a heads-up display on a motorcycle. There are automobiles with heads-up display in the windshield for speed and even what radio channel you're listening to, important stuff like that, right? So why can't we do that for the firefighter face gear? Why can't we? This technology exists. It exists. And we can have that technology there to tell the firefighter where they are in terms of having a little floor plan there if they want. Can be telling them what the room temperature is, what the visibility is, or they'd probably be able to see the visibility if they're there, right? But nevertheless, having temperature would be really useful. Give them some information about their own vitals of heart rate, breathing, body temperature, respiratory rate, blood pressure. All those kind of things could be incorporated in this heads-up display that the firefighter could be seeing to see, hey, I'm getting myself in trouble here, I need to back out, or for the incident commander to find them and see, hey, there's somebody that's getting in trouble here, we need to pull them out. As well as having a monitor on how much air is left in their tank of their breathing out. What's the surface temperature of their PPE. All existing capabilities technically, and my thought would be, and I agree or appreciate their costs associated with this, but I propose a lot of this doesn't exist yet because nobody's asked for it. Nobody's asked for it. And it's all there for the taking. It's all there for the taking of a greatly enhanced system that we have, that we do it for our military. Why can't we do it for our firefighters? I do want to just give a shout out for this group in particular. I think it would be really interested. We're planning a symposium in fall of 22. So it's a distance out yet, but we're teaming with NFPA and providing a fire and life safety ecosystem symposium in College Park. It'll be at the hotel. There'll be announcements the end of this calendar year starting to go out about that. And I would hope that the symposium would be of interest to many of you here. We're hoping to have a broad range of disciplines here with the ecosystem. They're not just engineers, not just firefighters that provide fire safety to community, but many, many disciplines that are involved. So we're hoping to attract many, many disciplines from the area, from perhaps from overseas, as well as from campus to attend this and to talk about this ecosystem for fire safety. With that, I thank you very much. I provide my contact info here if there are comments or questions and that you'd like to contact me beyond the workshop. Thanks very much.